Hello and welcome to a new Mendix Expert Developer webinar. My name is Jan de Vries and I will be your host for today. Today's webinar will be about application performance monitoring and will be presented by Arjen Lammers, technical consultant at Mendix, and Bart Tolen, specialist at Man Systems. During the webinar, you can submit your questions in the question window in GoToWebinar. After the presentation, we will go through them one by one. The questions and answers will be added to the webinar page afterwards. Before we start, please take a look at the Handouts window in GoToWebinar to find the presentation slides. Thank you for joining and enjoy the presentation. I'll now give the floor to Arjen.
Thank you, Jan, and welcome all. I would like to introduce ourselves. I'm Arjen Lammers. I'm a technical consultant at Mendix, and I help customers with technical challenges during development and runtime on aspects like performance and integrations. I also help them with architectural challenges which arise while setting up Mendix application landscapes. I've brought Bart Tolen with me, a performance specialist at Man Systems. He is also Mendix MVP, and he originally developed the APM tool. He helps customers solving performance problems. During this webinar, we would like to talk to you about what APM is, the APM components, when you want to apply APM, for real-life examples where you can apply APM during your daily work, a wrap-up summary, and the opportunity to ask questions. So, what actually is APM? APM is an add-on to the Mendix platform, and it complements the default available monitoring available on the Mendix cloud. The default available monitoring is all about your system resources. It will monitor your application and see how and report how your application is using the system resources. Instead, APM complements that by adding more information about what your application is actually doing. It has knowing about the inner working of your Mendix application, your actual model. It also applies on the end user experience. It reports to you how long a user has to wait until a result has been returned to the client. Applying APM gives you several benefits like faster issue resolution by giving you faster root cause analysis. It will help you increase end user productivity and satisfaction. It will also help you improve availability and stability of your application. So when you are using your application over time, the amount of users will grow and the amount of data will grow within your system. Eventually your system will get a lot of load on it. When that load reaches a certain threshold, your system will degrade in performance and also will affect your user experience, and your user experience can degrade in a very fast pace. Therefore, APM helps you and enables developers to detect application performance problems. It helps them diagnosing application performance problems, and it will help you keep up that level of service and user experience. So APM is an add-on which you can download from the App Store. At this moment it's still a module. Within 2017 we expect it to be delivered as a cloud service where you can just visit the website and view all the performance statistics of your application. When this model is included within your application, it will listen on the background on all the activities which are going on within your application. For example, a microflow which is being triggered by a user, or a retrieve for a certain object for a data view, or a query executed by a data grid. It will also listens for scheduled events which are executed in the background, and will also monitor all the queries which come out of it, like XPath, which is handled on, made on an application level, but also SQL, which is eventually going to your database. It will also record all the application logs which are going over the log connector. With all this information recorded, APM will give you tooling to perform a root cause analysis of performance-related issues. It will also help you to dramatically reduce the effort required to troubleshoot these kind of performance issues. It will also help you to analyze the actual uses of an application, because your application might be getting used differently than you expected in the first time. It will also help you to plot and predict usage of performance over time. Your performance might degrade. You want to gain a certain insight of it. APM consists of a lot of tools. The four main tools are displayed over here. We first have the trap tool, which is all about your application log. It will listen to all the logs which are going on within your system, and whenever an error occurs, it will store all the information which might be relevant for this certain error. It will record the deep level log information of what's happening within your system. Another tool is the performance tool, which enables the developer to capture a certain moment in time, and afterwards a developer will be able to analyze this. He can view all microflows and actions that were performed and drill down to each sub-microflow and microflow and query which was executed. The measurements tool is all about system resources, like your CPU usage or the memory consumption of your Java virtual machine. It can provide you of an application's current state and history, but also can be configured to record the state of your application when the consumption of system resources has reached a critical level. Another tool is a statistics tool, which is focused on the overall performance of your application. Here one can view how the system is actually being used and also overall performance indicators. Each application can sooner or later benefit from applying APM, but there are certain applications which are specifically identified as being beneficial for APM. Those are which are being heavily used, for example, a lot of users on them. Also those who deal with large volumes of data, for example, if you have batching processes in the background which deal with millions of records, then you want each block you have put within your microflow to be as efficient as possible. Other applications are mission critical. With those applications you can't afford any downtime of them or stability problems. That's why you want to apply APM on them to keep that level of service as high as possible. Other applications are those which are focused on the end user experience. You want them to give a reply as fast as possible to keep that user experience as best as possible. If you view the Mendix lifecycle, we can see we can capture user stories, we can develop those into a model, we can deploy them on production, and we can iterate over it to continuously improve our application. During this lifecycle, we've seen that on development we can apply APM to debug errors or performance issues which occur on production, and you can reproduce them locally, and to predict behavior of logic you have just developed to how it can behave on production. Another scenario is to apply APM during load tests, where you are simulating a lot of users at the same time on your system and want to find and identify bottlenecks. You can also use it on production to identify areas to improve on your application based on the actual behavior of your system. That way you can identify where you can put your effort in to optimize your system. You can also use it to discover the context of performance issues, or perform a root cause analysis of an error. A real-life customer example is a help desk which has 150 FTEs on it. Each of these users are handling tickets with a rate of 4 tickets an hour. An action menu which they had to use every time they handle a ticket would take up to 10 seconds, which caused also a significant load on the server. When we drilled down to the cause, we saw that 3 retrieves were responsible for each of them for 2 to 3 seconds. Then we started to optimize this, and we combined all those queries together into one query and also optimized it. When we looked at the server load, we saw a reduction of a factor 6, which is quite remarkable. Eventually, we saw that the action menu now only takes 1 second, which saves the user about 5 minutes of waiting per day. It also saves on the total staffing 750 minutes of waiting per day. That's about 1 FTE. It's quite remarkable that we also reduce the load on the server by a factor 6. That means that you can now handle 6 times more load with only 1 server instead of scaling up. Now Bart will handle the 4 examples of real application of APM during runtime.
Thank you, Arjen. Hello, everyone. My name is Bart Tolen. I work for Main Systems, and I'm the person who indeed developed the APM tool. I started it to solve my own issue when I ran across performance issues and didn't have tooling to solve it. Today I will show you 4 use cases, each covering a part of the usage of APM. I will start with the performance tool, and that tool can give you quick insight into performance issues if you can reproduce the issue. After that, I will tell you about how to use the performance tool during development so you can develop your logic the first time right. Next will be a use case about the statistics tool, and the statistics tool is about seeing what is happening on your system and preventing it. So basically, after your issue that you have solved with the performance tool, management will ask how can we prevent this next time. Well, the answer to that is 2 ways. First, during development, take performance into account, and second, try to predict what is happening on your production environment and prevent it from escalating. And the last use case I will present to you is about the trap tool to speed up error resolution. Let me get into the first case. Suppose you have a slow response in the GUI, or you have a long-running job like a batch or an export or a report. How are you going to solve that without APM? Are you going to do trial and error, or are you going to build in some statements to capture timings of certain steps? That's all cumbersome. You need multiple restarts, multiple deployments, and it is what it is, trial and error. And if you have found the issue and you've built a solution, how are you going to validate that solution? How do you know that it will work and is really faster? Well, with APM, you can measure the individual microflows, actions, even SQL statements, and you can discover the root cause of your problem a lot faster. And if you have found the root cause, you can start thinking about the solution, and if you have the solution, you can measure the solution, thereby dramatically reduce the time and effort to solve performance issues. Well, we have prepared a small case, so I will switch to the browser now. And over here you see a small demo application, the Task Manager. It's downloadable from the App Store, with the exception that we have added the APM tool, some use cases and a simulator. I will get back to those later. The APM tool can be opened from here, and you see the dashboard of APM. And on the dashboard you can immediately see information about your system. You see the statistics of the last couple of minutes. You see a measurement of, in this example, heap memory. You see the most recent errors that you can drill down to, and you see the logging. This is your first impression of how your system is doing. Now let's go to the performance tool and do the first use case. The performance tool can be found here in the menu, and the performance tool is a recorder. So we have to start recording to capture all the actions, microflows, SQL statements, and the first use case will be about counting the closed tasks. So I give the session a name and I press start. Now the performance tool is recording. So I will open the application again on another tab, so we keep the performance tool open, and here on the dashboard we prepared a use case with counting closed tasks. Now we can count in 2 different ways. We have the slow count, and the slow count retrieves a list of tasks, and then in a loop for every task we'll check if that task is a closed task. Of course, this is not the fastest way to do it, and there is a faster way where you retrieve the list of tasks and have a Mendix action do the count. So we call them the slow count and the fast count, just to illustrate how the performance tool is working. Now, I will do the slow count, and the slow count already takes about half a second with a few closed tasks. Now, to show you that this system has a lot more tasks, I will do the fast count as well, and the fast count shows over 100,000 tasks, 5 times as fast. So if I had not limited this list, it would take a very long time. Now let's look in the performance tool what we have recorded. So I switch back to another tab, the performance tool tab, I say stop, and it has recorded data. 8,000 actions, and mainly caused by the iterations in the loop. Now let's process the data. This will take 20 to 30 seconds, and at this moment it's storing all the data in the database, it's linking the information from different sources, the actions and the SQL statements are linked together, and normally you might want to filter data so it skips the actions that are very fast, say take 0 or 1 millisecond, and that's all part of the performance tool, but for this demonstration I just write down everything to the database. So on top of this list is now the slow microflow, and you see the execute action, that's the button action in the GUI, and that will trigger the microflow, and it took 461 milliseconds. It's sorted by duration. So let me use the show tree function to get an overview of what was happening. In this dialog you see the button that triggers the microflow, and let me zoom it in a little bit for you, and then you see the microflow, 461 milliseconds. It's called submicroflow, and in that submicroflow are the two steps, the retrieve of the list of tasks and the loop with, in this case, only 1500 tasks or iterations. And this takes up most of the time. Can you imagine how long it would take if you had over 100,000 tasks? Well, I can drill down here, and if I drill down I get a dialog with all the individual iterations. And I can see that the longest iteration only takes 2 milliseconds. And I can drill down to see what is happening in here, and it's only a start, a check, and this task wasn't one of the closed tasks because it immediately goes to the next iteration. But to optimize this issue, we would have to redesign, and then we get the fast query. Well, you can believe that it's a lot faster. I will show you in a moment on the list. Another thing you can do with the performance tool, if the issue was a query, you can take the action, look at the SQL statements the Mendix platform generates, and then ask the database for a query plan. A query plan is something that the database tells you how it will execute the query. In this case it says sequential scan, so it doesn't use an index, but it just follows the records in the database to find all the tasks. So even in this query there's room for optimization. And this feature really helps developers to solve the performance issues themselves, and that they do not need specialists to help them with it. This concludes my first use case, so I will close the dialogues and switch back to PowerPoint. And let me introduce the next use case. The next use case is a different use of the performance tool. What I said before, if you had a performance issue, management will ask you what can we do to prevent this. Well, the issue with performance is that if you have to redesign and refactor your issue, that takes time and has a lot of impact on your application, and it would be a lot better to do it the first time right. And also it's difficult to predict the performance of complex logic before you are in production. Of course, you've taken measures like getting a large database, but still, how do you exactly measure how your functionality behaves? Well, with APM you can avoid many of those performance issues exactly by measuring. And if you measure, and you optimize, you can measure again to see that your optimization has worked. And this really helps you to prevent the loss of end user productivity by having less performance issues in production. That will improve, of course, the user experience. And in the end, it also improves developer productivity, because instead of spending time on redesign and refactoring, they can spend time on new functionality. Well, as I said, besides taking care of performance during development, you can also prevent performance issues by looking at trends in production. And for that reason, we have another tool that's called the statistics tool. So suppose your app uses too much resources, or you see a degrading performance over time. It's not yet an issue, but your application is becoming slowish, and you do not really know which parts of your app are used or which parts are causing the issue. For this, we have the statistics tool. And the statistics tool tells you which actions are used the most, and also which actions are the most time consuming. And because it measures all the time and it stores that information daily, we can see a trend in, for example, the duration or the usage of the application. And with that trend, we can predict that it will be a performance issue in the future, and we can fix the performance issues long before they arise. And that has multiple benefits. You don't have downtime. You can fix the issues during your regular development process. You don't have escalations and special releases in between. So that has many advantages. Now let me show you the statistics tool briefly in a use case. I will switch again to the browser. The statistics tool is one of the tools in the menu, and it collects the statistics. But in this system right now, not much is happening, so let me switch to the Task Manager tab and start my simulation. If I start my simulation, all tasks, many tasks are created and closed in the background. And we can see that because if I now refresh, for example, my count will be different. It was 146 and it's now 159, and now again it's more. So these statistics are collected. These are the daily statistics. You see in this list microflows or client side activity, like a retrieve for a data grid, and you see how many times they are executed. You see the minimum, average and maximum duration, and also very important, the total duration, because that tells you about the impact on the system. The combination of duration and count gives you an indication that this amount of time is spent by this microflow on your system. Well, if we want to see how this microflow behaves over time, we open a dialog that shows you a trend. And if I think my system is a little bit too busy due to my simulation, so there it was, but let me stop the simulation first. It's very intensive, and head back for the APM tab and do that again. Should be a bit faster right now. And the graphs that we show here, there's a lot of data on my system, and these graphs will give you an indication of how much time each day this functionality has been executed, and also the durations. Here they are. And I can filter out the peaks and see that this microflow runs on quite a constant level over time. So for this microflow, there is no reason to be tuning, other than maybe the system in itself already uses too much system resources, and then we have to find out if we can give the system more resources, or for that reason try to optimize all the functionality anyway. Besides statistics and trend analysis, you can also see what is happening on the system right now. For that we have what we call the manual statistics. So we can reset, and after the reset we've cleared the counters, and if we turn on the simulator again we can see what is happening on the system right now at this moment in time, and see when I refresh all the time my scheduled events, I see the numbers change. This can really help us give insight into what is happening at a certain moment in time when maybe there is a high CPU or a slow response in your system. Those are the two main usages of the statistics tool. Now let me turn off the simulator again and switch back to PowerPoint. So my last use case will be about the trap tool, and that's a tool that helps you speed up the error resolution. Suppose the user has an issue and they can't reproduce the error, and the error occurs occasionally or at unpredictable moments. Then it's very difficult to solve the error because you can't reproduce it and you don't know when it happens. And especially if the log file also isn't telling you much, what would you do? You can turn on logging. That causes overhead on the system and a log file that may become very large and you might run out of disk space. Well, with APM we have a solution for that. We have a tool called the trap tool, and that works like your flight data recorder. It remembers all the trace and debug level logging of the entire system, and it remembers the couple of seconds before an error, or it remembers the last couple of seconds all the time, and when there is an error it will write those couple of seconds to the database. And with that information you have the context to analyze issues, and you can even see which actions were executed the last, so you have the right logging immediately instead of going back to the customer, asking them to turn on logging, and even worse, waiting a long time for the error to happen again. Now for this we also prepared a small use case, so let me switch for the last time to the browser. In APM we have a tool called the trap tool, and the trap tool is listening all the time, and when I switch to the demo application we have prepared a use case called check zip code, and the check zip code is calling a web service, and that web service performs a check. Only in this case we've written too many characters, so we can expect an error. Let me show you. I'll check, and this is what the client sees. Something went wrong, please contact your administrator, and your administrator has two errors in the Mendix console about couldn't handle the input parameters and an exception. And when you look at the stack trace you already have a lot of information. You can see that the zip code has a maximum length of 6 characters, and the user or the web service tried to insert 15 characters. Well, what you miss here is context. Should we enlarge the zip code field, or should we build a validation or go back to the other application that they prevent from sending so many characters? Now let me show you in the trap tool. In the trap tool you get the same 2 errors, and because they occur quickly after each other, the first one only collects a small list of low-level trace and debug messages, and when I go to the second one it is a lot longer list from the information that was available right before the error. Now let me filter the data a little bit here. The first message, or actually the last message, if you look at the time sorting, was the couldn't handle input parameters with the same stack trace that I've shown you in the screenshot. But what you can do with the trap tool is search for the message with the data. So here you have the entire web service message. Within it the zip code that has too many characters. So now you have the context to the error. Well, with this I would like to conclude my use cases and give the floor back to Arjen. I will switch to the PowerPoint for him. Here you are.
Thank you, Bart. So, besides the four main tools, there are several other tools available within the APM. Those are mainly power tools for developers. One example is the JVM browser, which is based on GMX. A developer can browse through all the mbeans which are set within the Java virtual machine and can gather more context. For example, if custom libraries are adding any beans to it, or view how the actual Java virtual machine has been set up. Another tool is the query tool. Instead of modifying your model and redeploying it to production and then performing your queries, you can also enter them and execute them during runtime using XPath, OQL or SQL. Another tool is the log tool, which records all the logs which are available within the system and will provide you with a way to search through them. Another feature of the log tool is to reroute custom logging from Java libraries to the Mendix default logging. To wrap it up, we have dramatically reduced the issue resolving time by gaining insight in an application's performance by analyzing recorded activities. By that, we can also gather more contextual information to an error, either if it's functional or performance related. We also increased the end-user experience and productivity by analyzing the overall usage of your application and identify parts of your application which can be improved to positively influence the user experience. We can also protect our applications against performance problems by making more efficient use of the system resources by improving functionality that affect your application the most. If you want more information about APM, you can find its documentation at the Mendix website. You can also download the module from the App Store.
All right, thank you very much, Bart and Arjen. That was a very nice presentation and some very cool demos. It's now time for questions. So if you have any questions about APM or the demos or what was explained by Arjen or Bart, please don't hesitate to enter your question in the questions window, and we'll go through them one by one. We already have a couple of questions. The first question is by Gunnar Eriksson, and he asks, the user satisfaction is also depends on the information being displayed. Is that correct? As well as the functions and the features. So let's see who is best to answer this one. I'll give this one to Arjen.
Of course, you're completely right. Performance is one of the aspects which can influence the customer, of the end user satisfaction.
All right. Will the tool itself degrade performance of the application?
I can answer that. Of course, the tool has a little impact, but we've gone out of our way to make sure that the impact is as low as possible, and we've done load tests with APM to measure that it's only a few % impact on your CPU or memory, and that's everything that it will impact your system.
All right, thank you. For the examples, did you also measure how much time a person waits, not because of a system slowness? So let's try to find out what's being asked exactly here. Yeah, I think it's for the customer example.
For the customer example,
How much time does a person have to wait because the system is slow, I guess?
No, not because of system slowness. I don't really understand the question, sorry.
Okay.
Maybe we can back at it later.
Wait time caused by the user. Okay, 1 second. Let's go to the next question, and I'll let this one. I'll let Bart and Arjen think about this one. Once the performance statistics are reported, can the APM tool also suggest ways of improving performance? Does the tool have certain standard values for performance?
Shall I answer this one? Right now the tool is mostly about measuring and presenting trends, but you have to do the suggestions yourself. Other than that, it may be sorting and showing you the information where the slowest query might be on top. And we are really working on in the future making sure that the tool will help you with notifications, with suggestions and stuff. So that's high on our roadmap.
All right, thank you. So Rob is asking, does the use of the APM module impact the application performance at all? Is there any reason not to always use it? So,
shall I answer?
Yeah, sure.
Yeah. Basically, at Systems we use this tool for many years now, and we always turn on the threat tool and the statistics tool. Those tools need to measure all the time to collect your statistics and be able to predict, and if there is an error, to trap the error. So, of course, what I answered in the earlier question, it has a little impact, but we've made sure that the impact is so low that you can run it all the time on production.
All right, thank you for the answer. Is APM compatible with Mendix 6.5?
Yes.
Wow, short and straight to the point. More questions like this. Would APM in the future also be able to make suggestions on how to improve performance issues?
I think we already answered that one. Yeah. And it's on the roadmap. Yeah.
Okay. Let's see, next question is from Achille. The App Store says that the APM tool is a paid-for add-on service. Can I download the APM tool and try it for free? How does that work?
Shall I? You can download the APM tool, but you need a license. And if you want to try it out, we can make available a cloud slot where you can look at the software. So you cannot try it out in your own model.
All right. Let's see. Is there a section on developers.mendix.com that gives advice or tips about microflow development best practices to prevent performance problems? There are some best practices documents on docs.mendix.com available. Some will talk about microflows. There are also a lot of forum topics available on microflow performance, and it's definitely something that we're looking to improve for the documentation, so extending this. So this is a good tip, actually, by letting us know what kind of information you're looking for, and we can try to improve the documentation as best as we can. So the next question is by Martin. Statistical data can be very useful but take up a lot of space. Can the statistical data be purged or archived by date and so on, or extracted for external analysis? I think this one's for Bart.
Yes, the APM solution has for all the data what we call a cleanup functionality, so you can configure that your statistics are purged if they are older than a year. And we have an OData interface, so you can extract or archive the data yourself to another solution. But you are right, if you collect statistics, it can take up a lot of space over time. So you have to do something. And the system automatically purchases for you after, by default, a year, but you could put that to a month if you want. And if you want to archive, you have to extract the data using OData.
Very nice. So lots of options for this. All right, looks like that's all the questions we had for today. About the earlier question from Gunnar about measuring how much time a person waits, we'll contact you directly, and so we can get some more details and go into it a little bit more. For now, I want to say thank you to everyone for attending the webinar, and I hope you enjoyed and learned some stuff about application performance monitoring. Please wait and sign up for the next webinar in December, and we'll hope to see you there. Thank you very much, and goodbye.